Electron configuration is how you can tell where electrons live in a specific element. So, like we just did chromium right now, you can pick any element and look at it in the periodic table and be able to use the periodic table to be able to determine how many rows, aka orbitals, aka energy shells, are in each atom, and the electrons rotating, are they rotating S, P, D, or F? And you can use your periodic table to do that. So let's do nitrogen. Let's look at nitrogen. If I want to get to nitrogen and I'm doing the electron configuration, I'm going to start at the top. Always start at the top. Work top, bottom, left to right. Row 1. Row 1. Look at row 1 and tell me what available orbitals exist in row 1. S, P, D, F, all, none, how many? Just an S, right? And what's the maximum amount of electrons that fit in an S? So what electron configuration is, you write the row number down, the orbitals that exist in that row, and the number of electrons per that orbital. So what comes after row 1? Anything else in row 1 other than an S shell? Nope. Then you have row 2. What exists in row 2? S, P, D, F, all, nothing? S and P. So you write it as 2S. What's the maximum electrons that can fit in S? 2. And then row 2, you write the 2 again, can hold a P shell. Now, we're trying to get to nitrogen. This is the electron configuration of nitrogen. Is nitrogen in the 2P, row 2, section P? Yes. How many electrons into P is nitrogen? Boron, carbon, nitrogen. So until you get to the orbital that houses the electron you're looking for, these numbers here are going to be the maximum electrons that can fit in that orbital. Once you get to the orbital, we were looking for 2p, then you put the number of electrons it takes to get to that element. So if we look at the 2p, we had boron, carbon, nitrogen, oxygen, fluorine, and then neon. So this is my 2p. Boron's the first one, carbon's the second, nitrogen is the third electron.